Hello, my name is Decker, and today you're going to be learning about graphs. This is a common graph. The origin is where the x-axis and the y-axis intersect. So, right there is the origin. We will be talking about quadrants. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, also known as positive, because anything right on the x-axis from the origin is positive. Anything up on the y-axis from the origin is positive. That is why it's positive. So, yeah. Any point on the graph is an ordered pair. So, say we have 1, 2, which would be right here. Would be, positive 1, positive 2. That's an ordered pair. So it'd be written like this. So 1, 2. Perfect. These are functions. So f parentheses x parentheses equals x, that's a function. Y equals x is the same. They're both the same. They're both functions. A function would look like this, or a type of function anyway. Y equals slope times x plus y-intercept. So here's how you get slope. Y sub 2 minus y sub 1 and x sub 2 minus x sub 1. Yeah. And you already know what the y and x sub 2 and y and x sub 1 are. They're just points on a graph that are from a line. This is direct variation, so y equals constant times x, and constant is k. Inverse variation is y equals constant over x, and this is what it looks like. The dotted line is the asymptote, or a line that is never hit when doing inverse variation. Good. And this is direct variation. This is what a graph should look like. At the top would be a title. On the left should be the y value, what the y value is equal to, and on the bottom is what the x value is equal to. The x value is often called x, or input, or independent variable, while y is often called y dependent variable, or output. This is the library of functions. It was passed out by Miss Lucas during the beginning of the year, or rather middle, somewhat. If you don't have this, it's very helpful. This is identity function, which is a straight line going through the origin rising right. And this is a constant function, which is just a straight line because there's no slope. This is what a squared function looks like, because since you're going into negatives, a negative times a negative would be equal to a positive. That is why it's a positive. And a cubed function is like this, because a negative times a negative times a negative is equal to a negative. There we go. And that's a square root. It goes like that. Absolute value function. It's like this because it's the distance away from 0. So if it's a negative, say -3, it'd still be 3 away from 0. And reciprocal function, which is the reciprocal of what you have. It looks like that. Since we know relatively how to make, or how graphs work, let's make a graph. At the top is the title, Apples to Oranges. On the left is the y value, or oranges. On the bottom is our x value, which is equal to apples. And here's our function, y equals 2x plus 1. So we plug it in. 0 times 2 is 0 plus 1. So that would be right here. And then we just plug it in with 1. 1 times 2 plus 1 equals 3. And we're starting to get a pattern here. It rises 2 every time, as we can tell. So 9. Okay, and then we just graph the line, and boom. But you try to get a straight edge to do that. I did not, because I'm running out of time. Yeah. Another graph that can be made would be finance, which doesn't have a function. It only does whatever you buy. So, this is how much money my sister uses, and this is every hour. This is money. This is in the thousands of dollars. So, she starts off with $5,000, and then she spends some money. But then my parents give her a lot of money, and then she spends it, and given, and then spends, and then given. But during finance, you can go into the negatives, and that would be called debt. And Josie goes into debt, but she's forgiven, so she gets more money. Graphs are usually used to compare things to something, or to look at, such as this graph. Yeah. Thank you for watching this video.